Good day. This is part 3 of the PowerPoint looking at applications of electrolysis. It's going to be pretty hard to see some of these things, so we're really more interested in the diagram. And you can see it's probably made over in England because this is how they spell aluminum in England, aluminium. But anyways, electrolyzing aluminum is an expensive process because it requires an enormous amount of electricity, plus it requires heat to have a molten electrolyte. So let's get right to this point. We're going to have a positive electrode. We're going to have a container typically made of carbon. And so the positive electrode, of course, is going to oxidize. And the negative electrode is going to be the site of reduction. Now, what we have is it says molten aluminum oxide. So the aluminum oxide is found in stuff called bauxite that's mined, but it has an incredibly high melting point of over 2,000 degrees Celsius. So when it's mixed with a chemical called cryolite, that reduces the melting point to under 1,000 degrees. And so you don't have to have as much heat, and of course that's easier on the equipment, although still pretty hot. So now we have our molten aluminum oxide. So what's really going to be happening here is that means we have our aluminum ions and our oxide ions. And the aluminum ions are going to reduce at the cathode, and the oxide ions will oxidize at the cathode. But we don't really care about that. What we care about is taking this aluminum oxide and getting our liquid aluminum. And then that gets drained off. And of course it's very hot. And then it gets poured out into whatever container you want to house it, and it may stay as solid and be remelted later on, or be put into the shape that you want immediately. Now, one of the things is because a purifying aluminum oxide like this with lots of electricity and lots of heat is expensive, it gives you a clue about why recycling aluminum cans is better. It's nicer to start with the pure aluminum, so you're not having to go through this expensive process. This animation is just going to give you some idea of what's going on. It's obviously very simplified, saying, hey, we only have to worry about the aluminum and the oxide. So here's the aluminum ions, and of course they're attracted to the cathode, and that's what's going to form the aluminum, and you can see they've changed the symbol to aluminum that's going to be drained off. And then the oxide is going to go there, and it may react and form some oxide, and eventually that will disintegrate. But that's an overview. I would suggest you read the section about how aluminum is purified in your textbook. Make sure you do that. That's it for that video.